Welcome everybody, and thank you for joining us today for the 7th and final webinar in EnSafe's Client Education Series. My name is Rich Heinzenberger. I'm a project manager here at EnSafe, and today's topic is developing a risk management program covering 40 CFR 68, and it's being presented by Kristen Gould. Kristen is a professional engineer and a project manager out of the EnSafe office in Londonderry, New Hampshire. And once again, welcome. Thank you for joining us. And Kristen, I'll turn it over to you.
Great. Thank you, Rich. Good afternoon, everyone. Thank you for spending your lunch break with me. I appreciate it, and I hope I can teach you something today. Like Rich said, my name is Kristen Gould. I studied chemical engineering, and I'm now a professional engineer in New Hampshire, Vermont, and Florida. My experience, I worked as a process engineer in industry for 5 years, and I've been an environmental consultant with EnSafe for 6. I've worked on developing RNP plans and conducting RNP audits at paint manufacturers, explosive manufacturers, and aerosol manufacturers, to name a few. This is our agenda today. I'm going to talk about the RNP rule history, what the RNP rule entails, the program levels under RNP, the 12 elements in an RNP prevention program, offsite consequence analysis, and updating the RNP plan. So why RNP? This dates back to the 1980s. In the 1980s, industry was booming, but EPA and OSHA did not have regulations in place to regulate chemical process safety. A number of catastrophic accidents took place at this time, which caused EPA and OSHA to take action. One of these accidents occurred in Bhopal, India. Many of you may be familiar with this tragedy because it made global news. What happened was there was a Union Carbide facility. There was an abandoned tank of methyl isocyanate, and there was still some product in the bottom of the tank. There was a pipe that was still attached to the tank, and it allowed water to trickle into the tank and form a chemical reaction with the remaining product. This expanded and exited the tank and created a toxic cloud, which was heavier than air, and settled on the adjacent city. The adjacent city was lower in elevation, and because it was heavier than air, the clouds did not disperse and go to lower concentrations very quickly. 2,500 people were killed, and 500,000 people were affected. This was the worst accident in industrial history. The causes were identified as poor safe management practices, poor early warning systems, and a lack of community preparedness. A lot of the community was not aware of the activities at the Union Carbide facility and the potential consequences. This accident, along with other similar accidents, motivated EPA and OSHA to develop chemical safety regulations. These regulations and the requirement for EPA and OSHA to take action came out as part of the 1990 Clean Air Act amendments. Within the Clean Air Act amendments, OSHA and EPA were required to develop chemical safety regulations, like I said. So OSHA addressed inside the fence being the manufacturer and property boundary. Their regulation is known as the Process Safety Management Standard, and it's found in 29 CFR 1910-119. EPA addressed outside the fence with the Chemical Accident Prevention Provisions, also known as Risk Management Program, and 40 CFR 68. Now there's a lot of overlap between the two regulations, but one or both may apply to the same process. The applicability is slightly different. Today, I'm going to focus on RNP. So the RNP rule applies to a specific list of chemicals and hazardous substances stored in excess of threshold amounts. The threshold amounts are in 40 CFR 68-130 and are based on the toxicity of the chemical. They range from 500 to 20,000 pounds. The RNP rule requires offsite consequence analysis of the worst case scenario released from a process. Worst case scenario, your largest storage tank ruptured. What could the impact of that possibly be on the community, and what would the radius of impact be? And I'll get to that later in the presentation. It also categorizes processes into program levels based on the type of process, the surrounding area, and accident history. There are 3 program levels, 1, 2, and 3. They get progressively more stringent as the number gets higher. And keep in mind, the program level applies to a process, not a facility. So if you have multiple RNP covered processes at your facility, they could be subject to different program levels based on the severity of the chemicals that they contain. Like I said, these are the RNP program levels, 1, 2, and 3. 1 is the least stringent. It is for processes which would not affect the public in the case of a worst case release. And you can demonstrate that with your offsite consequence analysis. Additionally, processes are eligible for program 1 if they have not had any incidents with offsite consequences within the past 5 years. So if you have a good track record with no incident history. Jump to program 3. Program 3 is the most stringent. Programs that are not eligible for program 1 and are either subject to OSHA's TSM standard or classified in one of 10 NAICS codes called out in the regulation. NAICS is the North American Industry Classification System. Okay, so program 1 has specific eligibility. Program 3 has specific eligibility. If you don't meet either, you're in program 2, which is like the medium severe program. It has some, but not all of the requirements that are in program 3. That's a lot of information. What I'm going to do now is talk about the prevention program requirement for program 3. Again, this is the most stringent program, and some, but not all of these are required in program 2. There are 12 elements in a program 3 prevention program. They're listed here: employee participation, process safety information, process hazard analysis, operating procedures, training, contractors, pre-startup safety review, mechanical integrity, hot work, management of change, incident investigation, and compliance audit. Some of these terms may be new. Many of these terms are not. For example, facilities are going to have operating procedures. They're going to have a training program. So the question becomes, do these programs meet the requirements under the RNP rules? So you might have to dust off your operating procedures and add more information into them, or same thing with training. There could be new pillars as well, like management of change, which you might not be familiar with. So I'll talk about each of these briefly. Employee participation. When it comes to safety in the workplace, who can best identify hazards and fixes, and who has the most to gain and the most to lose? Generally, our employees who work on the process are the most knowledgeable about the process. They normally know it like the back of their hand, and they can tell you what might go wrong and how often that's happened in the past. Additionally, they are going to be the first people impacted in the event of a catastrophic failure. And so it's really important to involve them in the process, to gain their insight, and to teach them and inform them about the safe practices. The RNP rule requires a written plan of action describing how employees are going to be pulled in to the RNP program. It must provide employees access to RNP information. And employees must be involved in other elements that I mentioned previously, including the process hazard analysis, process operating procedures, the mechanical integrity program, incident investigation, changes in the process, and emergency response. The next element is process safety information. The RNP standard requires that process safety information be recorded and maintained. This information helps ensure the system is designed properly and also helps inform other elements of the RNP program, like the process hazard analysis. Process safety information is normally called PSI, and it must include the hazards of the chemical, the physical properties, and the health effects. Oftentimes, this is documented in the form of safety data sheets. It must include process technology. What is the process chemistry, mass balance equations, heat and energy balances if applicable. if a reaction is taking place? What are the safe upper and lower limits of the process equipment? It also must include information on the process equipment like materials of construction, piping and instrumentation diagrams, RAGA, which stands for reasonable and generally accepted good engineering practices, release system design and design basis, and ventilation system design and design basis. What were the standards that this was designed in accordance with? Why? How does this equipment operate? What is it made out of? All of this information needs to be documented so that it will inform the process hazard analysis, etc. Like I said, the process hazard analysis is another one of the RNP pillars. A process hazard analysis is a thorough, systematic approach for identifying, evaluating, and controlling highly hazardous chemical processes. It basically entails a team sitting down and saying, walk me through the process. What could possibly go wrong? Why? Okay, and now if that took place, what are the consequences? What are the potential consequences? What mitigation is in place that we might be able to pull in here to reduce the likelihood of that happening? It has to be a methodical and systematic approach. There are documented techniques, including what if and has op, which might ring a bell. Those are generally the most familiar to people. The goal, like I said, is to decrease the likelihood and severity of a chemical accident or release. More about the PHA, like I said, it must be done by a team, and the team must include at least one member experienced in the process and at least one member knowledgeable about the PHA technique. So before I was saying HAZOP or what if, those are different techniques. So there's generally a leader, and then there's a team comprised of different process stakeholders. Within the PHA, a system must be developed for addressing recommendations and documenting resolutions and corrective actions. The PHA must be updated at least every 5 years, and the PHA and documentation must be kept for the life of the process. Operating procedures. Now, I'm sure everyone here is familiar with operating procedures, but the requirements under RNP are really specific for operating procedures. So like I said, this might be an instance where you take what you have and you evaluate it against the RNP rule, and you might have to add some information. As far as what's required under the rules, the operating procedures for the RNP covered process must include details on initial startup, normal operations, temporary and emergency operations, shutdown and startup following a shutdown or turnaround, lockout tagout, confined space entry, and any opening of process equipment or piping. It also must include operating limits and special or unique hazards. And it also must include safety and health considerations, chemical properties and hazards, what kind of PPE employees need to wear, control measures for exposure, consequence of deviations, and steps to avoid and correct deviations. So these are like operating procedures on steroids. There's a lot that needs to go into it. Training, like I mentioned before, operator training needs to occur initially and then every 3 years thereafter. And employers must document and maintain records of the date of training, who was trained, and how the employer verified this training. So what I mean by verification is, how did you confirm that they understood? Was there a test? That information should be included in the documentation. The topics must include operating procedures, safety and health hazards, emergency operations, and safe work practices. You're hearing probably a lot of repetition here. The 12 elements of RNP are designed to be interwoven. So training, operating procedures, and the process safety information all go hand in hand, right? And it's designed to be that way. Contractors. This section of the rule applies to contractors performing maintenance or repair, turnaround, major renovation, or any other kind of work on the RNP covered process. It does not apply to contractors providing janitorial work, food and drink services, laundry delivery, or anything else. This is contractors working on the RNP process. It's broken down into responsibilities for the owner and operator and contractor responsibilities. So the owner and operator needs to evaluate the contractor's safety performance. They need to provide safety and hazard information to the contractor of the potential fire, explosion, or toxic release hazards and emergency response before they work on your facility. They need to ensure safe practices and verify that the contractor acts responsibly. The contractor, in turn, must ensure training for its employees, ensure the employees know the process hazards and the applicable emergency actions, document training, ensure its employees are following the safe procedures, and filter up to the owner and operator any specific hazards associated with the work that the contractor is doing. Keys to compliance with this are to maintain a list of pre-qualified RNP contractors, which you can periodically update, perform contractor orientation, kickoff, and review of safe work permit, perform periodic and documented contractor inspections, emphasize the importance of contractors notifying the site of any non-routine work or near misses, and use interviews to determine if the contractors truly understand the hazards associated with the process and any unique safety precautions for working in the process areas. So if you're speaking to your contractor and they cannot communicate to you the hazards of the process they're dealing with, it sounds like they need some retraining, right? Hot work. Hot work means work involving electric or gas welding, cutting, brazing, or similar flame or spark producing operations. Permits must be issued for hot work conducted on or near the RNP covered process. The permit shall document the date authorized for hot work, the fire prevention and protection measures employed, and the object on which the hot work will be performed. And the hot work permit shall be kept on file until completion of the hot work operation. With regard to complying with the hot work safety prevention measures, the first choice should always be to evaluate safer alternatives before proceeding. For example, if a pipe was being welded, could the pipe be removed from a hazardous environment to a safer environment while that work is being done? Sometimes it's an option, sometimes it's not, but you want to think that through before you decide to proceed with working on it in place. Ensure there's a clear and consistent understanding of what work constitutes hot work. Verify that the contractors have provided fire watch and welder training, and evaluate the need for LEL monitoring in flammable liquid areas prior to the performance of hot work. If it's a flammable liquid area, there might already be LEL monitoring. If not, there are portable LEL meters. And when I say LEL, I mean low explosive limit. So we're talking about the concentration of a flammable vapor in the air. So in some cases, it's appropriate to carry a portable LEL meter with you. Finally, periodically review terminated hot work permits for completeness and accuracy. If they're not being completed correctly, they're not entirely filled out, or they seem to be filled out incorrectly, it sounds like it's time for some retraining on your hot work procedures. Mechanical integrity. A mechanical integrity program is required by the RNP standard to ensure the regulated process systems are maintained properly. This sounds obvious, but it's really, really important. The proper maintenance of equipment is vital to safe and efficient operation, right? The mechanical integrity standard basically requires owners and operators to develop a schedule that includes routine inspections and testing of equipment in the RNP process. The frequency of routine mechanical integrity should be based on equipment manufacturers' recommendations, industry standards, and/or RAGA gap, which I described before, the reasonable and generally accepted good engineering practices. Maintenance personnel will receive additional training on how the RNP mechanical integrity process will be conducted. For each inspection and test that is conducted as part of the MI program, documentation needs to include the date, the name of the person performing the test or inspection, the serial number or specific identifier of the equipment. Think about it. If you have 12 storage tanks and your form says, storage tank, pass the check, May 26th by Kristen, that's not helpful. Which storage tank? What was the test? What did you look for? So this needs to be really specific. And tell me the result of the inspection or test. So better documentation would say, May 26, 2021, Kristen Gould, tank 001, performed a visual inspection, no cracks and no leaks observed, passed. And then I might sign it. That would be sufficient documentation under the mechanical integrity schedule. Mechanical integrity ensures that the process is maintained in accordance with the manufacturer's specifications and industry standards. The easiest way to develop the schedule is to review the operating and maintenance manual provided by the manufacturer for each piece of equipment on the process. That's where you want to start. Listen to their recommendations, pull that into the schedule. Then there are industry tests like ASTM, the Steel Tank Institute, known as STI, and National Fire Protection Agency, NFPA, that will provide additional guidance on routine maintenance of process vessels. The mechanical integrity schedule must address pressure vessels and storage tanks, piping systems, release and vent systems and devices, emergency shutdown systems, controls, and pumps. Now, your RNP covered process might not have all of this equipment, that's fine. But for the equipment that is part of the process, these elements need to be included. Management of change. This may be a new one for those of you who do not currently have an RNP or a PSM covered process. Management of change is a procedure where a team evaluates a potential change, and it's methodical and thorough to make sure that everything is considered before implementing this change. It's not required for any process changes that are a change in kind. A change in kind is basically identical material of construction and operation. So if you're replacing a ball valve with a new ball valve that is the same size, same manufacturer, same material of construction, same gasket material, that would be a change in kind. If any of those variables that I just described are not the same, then that would not be a change in kind. Anything that is not a change in kind needs to go through the management of change process. This includes changes in process operation or technology, change in chemical and maximum intended inventory, safe upper and lower operating limits, changes in operating procedures, startup or shutdown steps, and then change in emergency shutdown systems. Considerations that should be addressed prior to any change. What is the technical basis for the change? What is the impact on safety and health? Do the operating procedures need to be modified? What is the necessary time period to implement this change? Who needs to authorize this change? Once all of that has been sorted out, employees that are affected by the change must be informed of the change before startup and trained in the change before startup. The process safety information may need to be updated, and the operating procedures may need to be updated. Again, this is where the elements are intertwined. So the management of change, again, is a methodical process for evaluating any change that's not a change in kind before the change is implemented, and during and after, as far as operating procedures and training. Now, the sister pillar to the management of change is the pre-startup safety review. The management of change handles evaluating and implementing the change. Pre-startup safety review is that last check before we go ahead and turn the switch on. The PSSR procedures should confirm that the equipment design was designed and installed in accordance with the design specifications. Operating procedures, maintenance, and emergency procedures are in place and have been updated if necessary. A process hazard analysis has been performed and recommendations implemented. The requirements and authorizations in the management of change have been met, and each employee which has been affected by the change has been trained. Finally, incident investigation. The rule requires the owner and operator to investigate each incident which resulted in or could have resulted in a catastrophic release. The goal of the investigation is to determine the root cause of the incident and then take appropriate action to prevent such an incident from occurring in the future. The incident investigation must occur within 48 hours following the incident. It must be performed by a team with at least one person knowledgeable in the process involved. Again, there's that employee participation. It must identify contributing factors to the incident and identify the root cause. And it must establish a system to address findings. This should all be culminated in a report, which includes the findings and recommendations, and it must be shared with the affected personnel. So if there's a group of employees who work on the RNP covered process, operators, maintenance, they need to be informed of the incident and the investigation and findings. The report must be retained for at least 5 years. Compliance audit. I believe this is our last pillar, so bear with me. We're almost through. The compliance audit must be conducted at least once every 3 years. At least one person involved in the audit must be knowledgeable about the process. The findings and subsequent recommendations must be documented, and you must keep the 2 most recent compliance audits on file. That'd be 2 every 3 years, so 6 years of compliance audit history. The point of the compliance audit is to verify the RNP program is adequate and adhered to. Adequate and adhered to, right? Does the program meet the requirements of the standards? And is the program being implemented effectively? Those are really important questions in order to make sure that the RNP program is robust and going to prevent any chemical accident if possible. It will at least reduce the likelihood and severity. Okay, we got through the 12 pillars of the prevention program. One thing that makes the RNP rule unique compared to the PSM program is that under RNP, as I alluded to before, owners and operators are required to conduct offsite consequence analysis. Offsite consequence analysis is required to provide information to the state, local, and federal governments and the public about the potential consequences of an accidental chemical release. There are 2 elements, the worst case release scenario and the alternate case release scenario. So this is what an offsite consequence analysis looks like. The offsite consequence analysis is performed using a software. The EPA has a free open source software called RNP Comp. It's available on their website. And so what you do is you put in the amount of chemical, the type of chemical from the RNP covered chemical list. It's the drop-down menu. So you select the chemical, put in the amount, and then you put in the physical state. Is it a liquid under pressure? Is it a liquid at ambient temperature? Is it a gas at ambient temperature? So you put in the physical state and information about the surrounding area. Is it urban? Is it rural? And then you click run. And what it will do is give you the distance to toxic endpoint. And that toxic endpoint is a concentration number, which varies for each chemical, and is provided in the appendix to the standard in 40 CFR 68. And so what it's telling you is in the event of this scenario, it would take X distance, usually given in miles, before the concentration of this chemical would drop below a hazardous level. Once you have that radius, you'll make a map like the ones here on the left. The location of the storage tank or process is in the center, and you draw a circle around it using that radius given to you by the modeling. Within that radius, you need to identify the population impacted and whether or not there are schools, commercial areas, recreational areas, et cetera, to quantify what is the risk here, what is the impact of this worst case scenario. I've been talking about the worst case, which is defined as the single instantaneous release of the largest single vessel in your process. So say you have a 5,000 gallon anhydrous ammonia tank. Say you have 3 of them. The worst case release would be considered to be the single release of one of those tanks, unless it could set off a chain reaction, which is not likely. So it would be taken to be the single release of one of those 5,000 gallon anhydrous ammonia tanks. Now that's not very likely to happen, and EPA understands that. So they also require an alternate release, which is really less defined, and it's based on any accidents that have happened previously at your facility or any accidents more likely to happen. For example, if you have a pipe sticking out from the tank, maybe the more likely scenario is a pipe rupture. And so you would do the offsite consequence analysis for that scenario as well, which is generally much, much smaller in volume and also occurring over a longer period of time. So the radius of impact is much smaller for the alternate release. And so you submit the results from both the worst case and the alternate case release as part of your RNP plan. So where is this all going? We need to, once we have all of this information put together, we have a prevention program at our facility. It complies with the requirements of the 12 pillars. We've done the offsite consequence analysis for both the worst case and the alternate case. We need to prepare a submittal to the EPA. This is generally done through EPA's Central Data Exchange website. Many of you are probably familiar with CDX from TRI reporting. So if you already have an account, that's fantastic. What you do is add this as a program service here on your welcome screen. We do this through EPA's eSubmit, RNP eSubmit. You see it here circled in red, and you would click and select Prepare Submission. There are 2 roles under RNP eSubmit, the preparer and the certifier. So the certifier would be your certifying official, and the preparer would be someone who has access to the facility information to put together the submittal. You make 1 RNP plan submission for each facility that includes all covered processes. So if you have 3 RNP covered processes, that's fine. What you'll do is you'll add all of that information as you build your submittal. As part of the submittal, you need to enter facility information, the toxic chemical information, the results of the offsite consequence analysis, and details from program 1, 2, or 3 prevention programs, depending on what applies. So everything that I spoke about up until this point gets pulled into the submittal, which goes to EPA. If you're unable to submit electronically, you are allowed to fill out a paper form, but if you do not use their official form, they cannot process your RNP. Just keep that in mind. Finally, communication with the public, because that's what this is all about, right? One of the major concerns about Bhopal was how the public was unaware and uninformed. And so the RNP rule requires that the RNP be made available to the public. Members of the public may obtain copies of the submitted RNP by requesting them from EPA in writing. Regarding the public's access to the RNP information, you should expect your community will discuss the hazards and risks associated with your facility as indicated on the RNP. You should be prepared and engaged in these discussions. The public and the press are likely to ask you questions because only you can provide specific answers about your facility and your accident prevention programs. The dialogue is the most important step in preventing chemical accidents, and it should be encouraged. So the best thing to do is to get out in front of it overly communicate, collaborate with the local emergency planning committee, the state emergency response commission, and other local state officials and interested parties. Not only will it make your life easier, that's also what this rule is all about, is preparing for and trying to prevent a catastrophic chemical release. And so in the event that your prevention program did not avoid an incident, you would want the community to be able to work together, evacuate people if necessary. The hospitals need to be prepared and ready. The firefighters need to be ready. And the community needs to be able to spring into action and do what needs to be done. So collaborating is really what it's all about. And again, because this information is available to the public, it's likely going to come up. With regard to RNP updates, the RNP must be updated at least once every 5 years from the date of the initial submission or most recent update, whichever is later. If there are any changes in your process, bringing a new chemical on site above the threshold quantity, or any changes that require a revised process hazard analysis, a revised offsite consequence analysis, or alters the program level that you're subject to, either 1, 2, or 3, then the RNP plan needs to be updated. Finally, I started the presentation by talking about an accident that happened in the 1980s, which stemmed these regulations to come out. But just because the chemical safety provisions and process safety management provisions have come out, it doesn't mean that accidents don't happen anymore. So I've picked this example, it happened in 2002. What happened was a chlorine transfer hose ruptured during a rail car unloading and released 48,000 pounds of chlorine over the period of 3 hours. 3 workers and 63 residents were hospitalized. So even with a stringent chemical safety program in place, accidents do happen. The best that we can do is to work to minimize the likelihood or severity of these accidents and work together to inform the employees and the public about the hazards of the process.
Well, we did have one question in the chat requesting that we summarize who is required to complete an RMP, including threshold levels.
Okay, sure. So owners and operators who have a regulated chemical above a threshold quantity in a process are required to prepare and submit an RMP. So the chemicals and the thresholds are listed in the regulation. If you want to jot it down, it's 40 CFR 68-130. So what that's going to give you is the list of chemicals and the threshold amount. So it'll give it to you in pounds. So then what you would have to do is say, do we have any of these chemicals on site? And if so, how much do we have on site? Okay, that's how you do the evaluation. And if it's above the threshold amount, you're subject to the RNP provision. The only thing I want to say about that is propane is on the list. A lot of facilities have propane. There's an exemption for fuel that is flammable substances that are combusted on site as fuel. So if you're using propane as for a backup generator, let's say, I don't know why you'd have that much on site, but let's just say you're combusting it on site for a backup generator, that would be exempt. But if you're using it as a propellant in your aerosol line, that is not exempt, okay? That's the only funny one. But besides that, it's pretty straightforward. I think it's 137 chemicals, and they're spelled out by name and CAS number.
Looks like we've got a follow-up question there.
Public and privately owned amounts. I'm not entirely sure what you mean by public and privately owned amounts, but this rule is applicable to facilities that have a covered chemical above the threshold amount at their site. So it even applies to federal facilities. They can mark things as classified. They have a little bit more leeway in what information goes to the public. But if you have above a threshold amount of an RNP covered chemical, you're subject. In county facilities, wastewater utility. My understanding is yes, that would still apply to you. My guess is if your wastewater, probably ammonia or chlorine. And there are specific guidance out there by EPA for ammonia and chlorine facilities, for wastewater treatment facilities. So yes, I'm not aware of any exclusions for state government facilities.
And we've included our contact information in the chat box for anybody that would like to request a copy of this presentation or to contact us directly. Looks like, Kristen, we do have another question here in the Q&A.
Okay, let me jump over there. Does the EPA review RNPs and do they ever reject them? Yes, they do review them. I'm not aware of them being rejected. One of the features, one of the good features, or bad, depending on how you look at it, is if you're completing an RNP on RNP e-submit, it won't let you submit if there are errors or if there are sections you haven't completed or if there's like conflicting data. You might get a warning or you might get an all-out error which says you have to fix this before you proceed. So there's a little bit of built-in screening, but then yes. When I looked at the guidance documents, it doesn't say EPA reviews every 3 years and they do a site visit to confirm. I don't think it's that specified, but the information goes to EPA and I think we can assume that they're reviewing it. It's there for their access. And especially, I hate to say it, but especially if there's an accident, they might go back and nitpick. But yes, once it's submitted online, it's in their hands and they don't have a set schedule for review or audit, but I guess you would say that it's in their hands at that point.
Thank you.
I'm not aware of rejecting the plan besides the automatic warnings that come up when you're submitting online. And I suppose if you were submitting through their form and it was completed incorrectly and you mailed in the hard copy, they might send you back a request for additional information or some corrections that are required. But honestly, in all of the RNPs that I've been involved in preparing, we use the online submittal. So I think that it's faster and also it might help it be processed faster as well. The question is, how often does the EPA conduct audits on facilities? Not specified. I know a lot of facilities with air permits, they can expect to be have a visit by the regulating authority at least once during the permit cycle. In the guidance documentation, I could not find that same verbiage for the RNP plan. So again, I think they might be a little more reactive than proactive when it comes to visiting RNP facilities, but it's not specified how often the EPA audits facilities. Again, the compliance audit is done by a team, not the regulating authority, and that happens every 3 years. But as far as a visit from the EPA, there's no set schedule.
Thank you again, Kristen. Great job on illustrating just how imperative an RNP program is to preventing a catastrophic and desolate situation. Once again, thank you everybody for attending today. We really appreciate it. This has been a very successful client education series for us. If we did not get to your question, please feel free to submit it to either Kristen or myself. Our email addresses are in the chat box. And once again, thank you again for joining us. And this concludes our presentation.
Thank you, everyone.
Thanks, Kristen.